We're going to do some solenoid testing. And we can use a voltmeter, DVOM. But the thing you want to keep in mind is solenoid operation and relay operation is magnets. If it's a magnet, there will be times you might want to use an ammeter. And we're going to talk about that too. The facts don't change between the different circuits. We've got a number of different things. It can be relays, it can be solenoids, it can be fuel injectors. The way they test is the same. An electrical current is going to cause a magnetic field, which in turn is going to produce a change. It's going to open a valve. It's going to close a switch. It's going to do something along that line. The typical things you're going to see are fuel injectors, starter solenoids, trunk releases, idle air control solenoids. Keep in mind, sometimes they're stepper motors. Canister purge solenoids, door locks. So what we're going to do, we have two kinds of solenoid. The first we'll talk about are high side, B+ controlled solenoids. They all test the same. I could have a B+ solenoid for a trunk release, for anything I want, and it's going to work this way. I've got B+ on the left. I've got a switch that's going to open and close. Now, what voltage should I expect to see when I've hooked to ground with my black lead and I hook to the high side solenoid with the switch energized? What should I see here? Should be B+. I know this sounds simple. Bear with me. It'll get more complicated. B side, the ground side. What voltage should I see here? Better be low voltage. 20 millivolts in this particular case. All right, let's change the ground side control, low side. What voltage should be present here? B+, all the time. That's an easy one. Now, I'm on the other side of the solenoid. I'm on the ground side of the solenoid with the switch open. What voltage do I expect to see? B+. Why? It's an open circuit. Back to our silly basics we went through early. We don't have current flow. We don't have a voltage drop. Well, let me say that again. If we don't have current flow, we don't have a voltage drop. With the circuit open like this, there is no current flow. So we're going to read B+. Some people are confused by that because when it closes, they say, well, yeah, but when it closes, it reaches a real low voltage. I'm only reading 0.7 volts. That's because it's on, current is flowing, and we have dropped most of the voltage through the solenoid or relay. Let me say that again. We've closed the ground, we started current flow, and most of the voltage in the circuit has been dropped by the solenoid or relay coil. That's why it's low. It should be low. We could do the same thing. Here we can take and measure current flow. An ammeter can be used to complete the circuit to make this measurement. I can take my red lead, put it over into the amps section on the far left of this meter, which makes this an ammeter, run the current through the meter back to ground, and I can energize the solenoid with my meter. What did I do that for? Well, it tells me if all the circuitry is good, all the way back to B+, and if ground is good. If I got normal current flow, I'm done. All you need is a good specification. Use vehicle-specific information and look up the resistance value. Know what you're looking at and expect occasionally to find a bad wire like the one we got shown here at the top. Remember, if a wire's that bad and we've lost a good part of our conductors, we probably can't draw full current flow. These coils are all made up of wire. We can read ohms, we can read the voltage. Here's one we cut open so you can see what's inside. These are not highly precise creatures. They're just wires wound around a core. So keep this in mind. It's simple. Use good basic testing and the stuff we used in basics, and we can verify it. And again, amperage tells us if everything is right. How many times have we said that?